Welcome to Easy BTech. Please subscribe the Easy BTech channel. It gives an extended knowledge with international standards. Today we have learned about the definition of matrix and the types of matrix. What is matrix? A system of mn numbers. These numbers either real or complex or functions. These numbers are either real numbers or complex numbers or functions arranged in the form of ordered set of m rows each row consisting n numbers, each row consisting n numbers between the brackets, either square bracket or like open bracket and also norm bracket, is called a matrix of order or type m by n. In generally, the matrix of order m by n is denoted by A11, A12 up to A1n, A21, A22 up to A2n, A31, A32, similarly A3n, AM1, AM2 and so on to AMN. This in generally an order m by n matrix is denoted by A11, A12 up to A1n and A21, A22 up to A2n. Similarly, AM1, AM2 up to AMN. So, for our easy, it is denoted by a matrix Aij, where here I is from 1 to m and j from 1 to n. So simply it is denoted by Aij. Here I is from 1 to m and j from 1 to n. Okay, once again see a system of mn numbers. These numbers either real numbers or complex numbers or functions arranged in the form of ordered set of m rows, each row consisting n numbers between these brackets is called a matrix of order or type m by n. In general, the matrix of order m by n is denoted by A11. This means first row. A11 means it denotes first row, first column. A12 it denotes first row, second column. Similarly, A1n it denotes first row, nth column. So this here, if you observe, here there is a m rows. So here m means m denotes the number of rows. Here there is a m rows and here there is n columns. So n denotes columns. So here this order is m by n. So if you write any order, first we have to write the number of, first in the order, first we have to write number of rows into number of columns. That is the order of the matrix. Suppose order of matrix. Order of matrix equals to first number of rows into number of columns. So this is the order. Simply it is denoted by m by n. It is read as m by n. So this is the definition of matrix. See some of the examples for the definition of matrix. Suppose capital A equals to -1 0 2 1 -1 6 3 2 -4. If you observe here there is a first, if you want find the order, first we have to count how many rows are there. This is the first row, 1 -1 6 second row, and 3 2 -1 this is the third row. So here first we have to write the number of rows. Here there is a total three number of rows are here. And how many columns are there? First column 1 -1 3 0 -1 2 second column 2 6 -4 this is the third column. So there is a three columns, therefore 3 by 3. So this is the order of the matrix. So this matrix contains rows and also corresponding columns. Now here important note. What is the note here? The numbers in the matrix, the numbers in the matrix are denoted by small letters. The entire matrix, the entire matrix denoted by capital letters. Suppose for example, capital A equals to A, B, C, D, E, F. If you see this example, in this example, this entire matrix capital A, this capital A denotes entire matrix. Here, these elements, here A, B, C, D, E, F, these elements denote, these elements, here, these are all elements are small letters. Okay, here the capital A denotes the entire matrix. A, B, C, D, E, F, these are the small letters. It denotes the elements. So here this notice the numbers in the matrix are denoted by small letters like A, B, C, D, D, E, F, and the entire matrix. Here the capital A is the entire, capital A denotes the entire matrix. So this is the important note. Okay. Now come to the next one. Types of matrix. Types of matrices. Types of matrices. Now we have to discuss some of the important types of matrices. In this first one is square matrix. Square matrix. A matrix, a matrix in which the number of rows, the number of rows is equals to number of columns, is equals to number of columns. A matrix in which number of rows is equals to the number of columns is called square matrix. See an example here. See an example. Capital A, capital letters denotes the entire matrix. Small letters 2, 4, 6 are A, B, C. This is the one matrix. Here the small a, b, c, these are the elements of the matrix are numbers of the matrix. Capital A denotes the entire matrix. So if you see this matrix, it is not a square matrix. Why? Because 2, 4, 6, this is the one row. A, B, C, this is the one row. Here number of rows m means number of rows equals to 2 and the number of columns n equals to 3. 2a, 4b, 6c. So 3 rows, 2 rows and 3 columns. So it is not a square matrix. Therefore, here -1, 0, 2. Now if you see, there is a 3 columns and 3 rows, 2, 4, 6. First row, A, B, C, second row, -1, 0, 2. This is the third row. So now there is a total 3 rows. Now there is total 3 rows and 3 columns. So number of rows are 3, number of columns also 3. Therefore, m equals to n. So that means number of rows equals to number of columns. Therefore, A is a square matrix. Square matrix. Square matrix means number of rows equals to number of columns. This order is 3 by 3. 3 means first 3 is number of rows, the second 3 is number of columns. This is the square matrix. Now come to the next type of matrix is rectangular matrix. Rectangular matrix. So this is the in the rectangle already generally already you know, if you take a square, the length and breadth both are equal, but in the rectangle length and breadth are need not be equal. Here also the number of rows equals to number of columns, then it is called a square matrix. Suppose the number of rows is not equals to number of columns, then it is called rectangular matrix. See the definition: a matrix in which number of rows not equals to number of columns. That means m is not equals to n. That means m is not equals to n is called rectangular matrix. Is called rectangular matrix. See an example. See an example. Sub B. This is the capital letter. This B denotes the entire matrix. A, B, C, D, E, F. If you see this matrix, in this matrix A, B, C, this is the first row. D, E, F is the second row. Therefore, here there is a two rows. Two rows. Therefore, 2 by how many columns? AD one column, BE second column, CF third column. Therefore, there is a 3 columns. Therefore, here number of rows m equals to 2, number of columns n equals to 3. Therefore, here m is not equals to n. Therefore, B is a rectangular matrix. It is not a square matrix. Rectangular matrix. So just see one more example. Suppose for example capital C equals to 3, 4, 6, 0. If you see this one, here there is a only one row, 3, 4, 6, 0. This is the only one row, 1 into columns. 3 is the one column, 4 is the one column, 6 is the one column, and 0 is the one column. Therefore, there is a total 4 columns. Therefore, m equals to number of rows equals to 1 and a number of columns n equals to 4. Here m is not equals to n. Therefore, here C is a rectangular matrix. C is a rectangular matrix. So these are the two examples of rectangular matrix. Now come to the next matrix, row matrix. What is the row matrix? Row matrix. A matrix having a single row, that means simply the m equals to 1, is called a row matrix. Is called a row matrix. It is also called row vector. It is also called row vector. See an example. A matrix having a single row, that means m value equals to 1. That means suppose for example, some matrix K equals to -1, 0, 3, 2, 4. If you observe here, there is a only single row. Therefore, m equals to 1. Number of rows, m equals to 1. Columns, -1, 1 column, 0, 1 column, 3, 1 column, 2, 1 column, 4, 1 column. Here there is a total 5 columns. Therefore, n equals to 5. Therefore, order is 1 by 5. So, in this matrix, there is a single row is there. Therefore, this is called row matrix. Similarly, we can discuss the column matrix. So, the next definition is column matrix. The next definition is column matrix. A matrix having a single column, that means here n equals to 1, is called a column matrix. It is also called column vector. See an example. Some m equals to, here m denotes the entire matrix. Some m equals to A, E, I, O, U. A, E, I, O, U. So this is, if you observe, here A is the one column, E is the one column, I is the one column, 0 one column, and U is the one column. Therefore, here number of columns are 1, 2, 3, 4, 5. Therefore, number of rows. A is the first row, E is the second row, I is the third row, and 0 is the fourth row, and U is the fifth row. Therefore, number of rows M equals to 5. See the columns A, E, I, O, U. There is a only single column is here. Therefore, n equals to 1. So, order of this matrix is 5 by 1. Therefore, it is a column matrix. That means a matrix contains a single column. Then it is called column matrix. Therefore, it is a column matrix. It is a column matrix. This column matrix is also called column vector. Similarly, the row matrix is also called row vector. This is the very important. Why? Because the column vector and row vector we will use in the next topic. Now come to the next type of matrix is null matrix or zero matrix. Null matrix or it is also called zero matrix. This null matrix or zero matrix is denoted by 0 into some m by n. So it is denoted by 0 or O. Here the zero matrix. So every element, suppose every element of a matrix is 0. That means every element is of a matrix is 0, then the matrix is said to be zero matrix and it is denoted by 0. So if, see the definition, if every element of a matrix is 0, then the matrix is called zero matrix. Then the matrix is called zero matrix. See an example. It is denoted by 0 m by n. M means number of rows, n means number of columns. See an example. 0 equals to every element of a matrix is 0. Every element, that means first all the elements are 0. Not only one element, every element is 0. Then the matrix is denoted by 0 matrix. Here there is a total number of rows equals to 3, 1, 2, 3, and a number of columns 1, 2, 3, 4, that equals to 4. So this 0 matrix is simply denoted by 0, 3 by 4. So number of rows 3, number of columns 4. So this is the 0 matrix. 0 matrix means every element of the matrix is 0, then it is called 0 matrix. Now come to the principal diagonal. This is the very important concept. Principal diagonal. What is this principal diagonal? So before discussing this definition of principal diagonal, first we have to keep one point in our brain. What is that? The principal diagonal is only for square matrix. If you take the rectangular matrix, we can't discuss the principal diagonal. If you want to require the principal diagonal, first the matrix should be square matrix. Only square matrices only having a principal diagonal. Rectangular matrices does not have the principal diagonal. So if you discuss the principal diagonal of a matrix, first of all we have to test that matrix is principal, that matrix is square matrix or not. Okay, that is a very important point. Here see the principal diagonal in a square matrix. In a square matrix, in a square matrix, all these all those elements aij equals to all the elements aij for I equals to j are called principal diagonal elements. In a square matrix, see the definition. In a square matrix, that means first of all that matrix should be square matrix. In a square matrix, all these elements, which elements? Aij for I equals to j are called principal diagonal elements. Are called principal diagonal elements of the matrix. Keep this point. What is this? What is this Aij for I equals to j? Keep this point. It is the very very important to you. I equals to j. I equals to j means I and j both are same. That means if you see the example, you can easily understand. Here what they are telling, suppose for example A equals to, suppose for example capital A equals to, already I told to you in generally the matrix is denoted by A11, A12, A13 and so on, A1n. A21, A22, A23 and so on, A2n. Similarly, A31, A32, A33 and so on, A3n. Similarly, the last suppose the AM1, mth row, AM2, AM3 and so on, AM n. But this is the matrix of, clearly understand, this is the matrix of order m by n. If m is not equals to n, then it is a rectangular matrix. But what I told to you here, here I clearly told to you the matrix is a square matrix. That's why matrix is a square matrix. Square matrix means m and n both are same. Therefore here we have to take m by n. This is the actually this is the m by n matrix. But if you want to discuss the principal diagonal of a matrix, that matrix must be square matrix. That's why here I am telling you, here we have to take, here we have to take m rows and m columns. Therefore instead of m we have to write only n. Why? Because we have to take the m rows and m columns. That's why this is up to a n1, a n2, a n3 up to a nn. That means n by n. N by n means number of rows n, number of columns also n. So columns and rows both are same. Therefore this is called the square matrix. In the square matrix, what I told to you, Aij, Aij, if I equals to j. I equals to j means I and j both are equal. Here if you observe, here A11, I value is 1, j value is also 1. That means I equals to, here I equals to j equals to 1. I equals to j equals to 1 means A11. And I equals to j equals to 2 means A22. And I equals to j equals to 3 means A33. Similarly, up to last, I equals to j equals to n equals to a n n. These are all the elements. What are the elements? These elements. These are all the elements are called principal diagonal elements. That means here principal diagonal elements are A11, A12, sorry, A22, A33 up to ANN. These are the principal diagonal elements. Okay, that is Aij. So keep this point. This is the very very important to you. Once again, I will repeat the definition. Check it. In a square matrix, all the elements Aij for I equals to j are called principal diagonal elements of the matrix. That means the principal diagonals means we have to take the only elements where I equals to j. Where I equals to j means which are on the only diagonal. This is called the diagonal. If you observe clearly here in the square, in the square, this is the diagonal. This diagonal is called principal diagonal. These elements are called principal diagonal elements. So this is the principal diagonal. Now come to the next one. Now come to the next definition. Now come to the next definition. Now come to the next definition. This is the only principal diagonal. What are the principal diagonal matrix? Yeah. Now come to the next one. Diagonal matrix. Principal diagonal elements or principal diagonal is different and diagonal matrix is different. Principal diagonal means in a square matrix, all the elements lying in principal diagonal. That is called the principal diagonal. The elements which are in the diagonal are called the diagonal elements. But here the diagonal matrix is different. A square matrix, a square matrix in which in which all non-diagonal elements are zero is called diagonal matrix. All non-diagonal elements are zero. But before discussing this definition, first we have to understand here we have to see only the square matrix. This is the very important. And a non-diagonal means already we discussed in the last example diagonal. Now what is the non-diagonal? See this example. Suppose for example some matrix capital D equals to -1 2 0 6 and 0 5 2 3 and 3 4 -2 7 and -1 4 0 0. If you see this one, first of all we have to test the given matrix is a square matrix or not. Is it check? Is it square matrix? Why? Because how many rows are here? 1 2 3 4. Therefore number of rows m equals to 4. See the number of columns 1 2 3 4. Number of columns n equals to 4. Therefore here number of rows and number of columns both are equal. Therefore this is the square matrix. Therefore this is square matrix of order 4 by 4. So this is the square matrix. So if it is a square matrix, we can find the principal diagonal. First see the principal diagonal. What is the principal diagonal here? This is the first row, first element, second row, second element, third row, third element, and fourth row, fourth element. This is called the principal diagonal. These elements are called the principal diagonal elements. Therefore here principal diagonal elements are principal diagonal elements. These principal diagonal elements are -1 5 -2 7. These are the principal diagonal elements. But this matrix is not a diagonal matrix. Why? Because this is called the, sorry, here 1 minute. Yeah, see, just a minute my dear students. Yeah, see this one. Yeah, just a minute. Yes, this is 7, this is some 2. Yeah, see if you observe here the principal diagonal is -1 5 -2 7. This is the principal diagonal elements. But the remaining elements, so which are in this uh, line, in this principal diagonal, that elements are called the principal diagonal elements. So remaining elements which are below and which are above the principal diagonal, these elements are called the non-diagonal elements. So these non-diagonal elements must be 0, but here these are not equals to 0. Therefore it is not a diagonal matrix. It is not a diagonal matrix. So keep this point, it is the very important. It is not a diagonal matrix. Why? Because non-diagonal elements means which are above the diagonal and which are below the diagonal. These elements are called the non-diagonal elements. So here the non-diagonal elements are not equal to 0, therefore it is not a diagonal matrix. See another example. Suppose for example some A equals to A 0 0 and 0 B 0 0 0 C. If you see this one here, First see the, is it square matrix or not? It is a square matrix. Why? Because here there is a 3 rows and 3 columns. Therefore, it is a principal, it is a square matrix. This order is 3 by 3. 3 by 3 means it is a square matrix. So, if it is a square matrix, it has a principal diagonal. What is the principal diagonal here? See this one, ABC. ABC is the principal diagonal. First row, first element, second row, second element, and third row, third element. So, this is the principal diagonal. So, all the other than the principal diagonal, all are 0. So, here all non-diagonal elements, non-diagonal elements all non-diagonal elements are 0. All non-diagonal elements are 0. Therefore, it is a diagonal matrix. Therefore, it is diagonal matrix. So, just understand the difference between the above example and the below example. In the above example, the principal diagonal is -1, 5, -2, 7. But here the principal diagonal is A, B, C. So here in the above example, above the principal diagonal, all elements are not 0, and below the principal diagonal, all are not 0. Therefore, this D, the matrix D is not a diagonal matrix. Why? Because non-diagonal elements are not equals to 0 here. But in this example, A, B, C, this is the diagonal elements are principal diagonal, but above the principal diagonal all are 0, 0, 0, 0, and below the principal diagonal also 0, 0, 0. Therefore, this is called the diagonal matrix. The diagonal matrix means except the diagonal elements, all elements are must be 0. So this is the principal diagonal matrix. See one more example for the principal diagonal matrix. See the one more example of the principal diagonal matrix. Capital A equals to DIGA of 2, 4, 0, -1. So this is the principal diagonal matrix. It is denoted by DIGA. What is the meaning of DIGA? Here this means these are the only diagonal elements. 2, 4, 0, -1. These are the only diagonal elements. Remaining elements are must be 0. So it is a diagonal matrix. Diagonal matrix. What is the meaning of why it is diagonal matrix? They given only one row here, but in front of this matrix, this row matrix, there is a DIGA. That means this is the meaning of diagonal matrix. So the full form of this diagonal matrix is first row first element 2, second row second element is 4, third row third element is 0, fourth row fourth element is -1. This is the principal diagonal elements. These are the principal diagonal elements. Remaining all elements are 0. That means 0. That means 0, 0, 0, 0, 0. And here also 0. Here also it is 0, 0, 0, 0, 0. This is the 4 by 4 matrix. This is the 4 by 4 matrix. 4 by 4 matrix. M equals to 4. N equals to 4. Here 2, 4, 0, -1. This is the principal diagonal elements or principal diagonal. Above the principal diagonal all are 0, and also below the principal diagonal also all are 0. So therefore this is simply we will write DIGA, that means diagonal matrix of 2, 4, 0, -1. Why? Because the remaining all elements are 0. Therefore simply we will write like this. So that means a principal diagonal matrix is simply denoted by DIGA. DIGA in brackets only principal diagonal elements. Then this is the one more example of principal diagonal matrix. Now come to the scalar matrix. What is the scalar matrix? See the next one. The next one is scalar matrix. So scalar matrix. If all the okay in a diagonal matrix, in a diagonal matrix in a diagonal matrix, all diagonal elements are same, then then it is called then it is called scalar matrix. If you observe this definition, in this definition we have to observe one thing in a diagonal matrix. That means first we have to take the diagonal matrix. That is very very important. First we have to take the diagonal matrix. In this diagonal matrix all the diagonal elements are same. Then it is called a scalar matrix. Suppose for example I will tell you one of the example. See this example. Some example C equals to 200,040,001. If you see here, it is a, see the principal diagonal here. Here the principal diagonal is 241. 241, this is the principal diagonal, this is the diagonal matrix. Why? Because above the principal diagonal all elements are 0 and below the principal diagonal all elements are 0, therefore it is a diagonal matrix, but it is not a scalar matrix. So what is the scalar matrix? In a diagonal matrix, that means this is the diagonal matrix, all diagonal elements are same, but here 241, 241, these are the diagonal elements, 241 not equal, these are not same. Therefore, it is not a scalar matrix. Suppose, for example, in this matrix, suppose, for example, see, this is, suppose this is not a 4 and also this is also, suppose, for example, it is also not equals to 4. Yeah. See, suppose, for example, 2, 2, 2. Now check it. This is the principal diagonal. Principal diagonal is 2, 2, 2. Above the principal diagonal all are 0, below the principal diagonal all are 0. This is the square matrix. In this square matrix, sorry, first of all, this is the square matrix. This order is 3 by 3, 3 rows and 3 columns. This is the square matrix. And above the principal diagonal all are 0, below the principal diagonal all are 0. Therefore, it is a diagonal matrix. See the diagonal elements. All the diagonal elements are same. So, therefore, it is a scalar matrix. Scalar matrix means we have to keep the 3 points. First one is square matrix. First one is square matrix. Second one is diagonal matrix. And the third one is all diagonal elements are equal. All diagonal elements are same. See this, you have to observe these 3 points. First one is square matrix. This is order 3 rows, 3 columns. Therefore, it is a square matrix. Come to the second point, diagonal matrix. It is a diagonal matrix. Why? Because above the elements to the principal diagonal all are 0 and all elements below the principal diagonal also 0. Therefore, this is the diagonal matrix. Come to the third point, all diagonal elements are same. 2, 2, 2. All are same. Therefore, it is called a scalar matrix. So, this is the very important, my dear students. Now, come to the next one, symmetric matrix. Okay, before going to discuss the symmetric matrix, we have to discuss the unit matrix. Unit matrix. Unit matrix. It is also called identity matrix. Identity matrix. It is simply denoted by capital I. It is simply denoted by capital I. But already you know the square matrix. In a square, okay, not square matrix, in a scalar matrix, all the diagonal elements are equals to 1, then it is called unit matrix. Then it is called unit matrix. Okay. Here the unit matrix in scalar matrix, all the diagonal elements are equals to 1. Then it is called unit matrix. So what is this meaning? Suppose for example, I will tell you one example. Scalar matrix. Scalar matrix means in the already I told to you, scalar matrix means suppose for example, capital A equals to 300,030,003. This is the scalar matrix. Why it is scalar matrix? Why it is scalar matrix? It is the square matrix. First one, it is the square matrix. Point number one, square matrix. Why? Because this order 3 rows and 3 columns. Therefore, it is a square matrix. Second one is, it is a diagonal matrix. Diagonal matrix. Why? Because above the principal diagonal, this is the principal diagonal. Above the principal diagonal, all are 0, and below the principal diagonal, all elements are 0. Therefore, it is a diagonal matrix. The third one is, this is scalar matrix. This is the scalar matrix. Scalar matrix means all the diagonal elements are same. 3, 3, 3. All the diagonal elements are same. Therefore, this is the scalar matrix. But it is not a unit matrix. When does we say it is a unit matrix? In a scalar matrix, all the diagonal elements are equals to 1. It is a very, very important. But here all the diagonal elements are equals to 3. Therefore, it is not a unit matrix. It is the only scalar matrix. Suppose for example, in this scalar matrix, all these elements are equals to 1. Suppose this is 3, this is also 3, and this is also 3. Suppose for example, these are all the elements are equals to 1, 1, 1, then it is called unit matrix. Therefore, A is a unit matrix. Why it is unit matrix? All the diagonal elements are equals to 1, 1, 1, equals to 1. Therefore, it is the unit matrix. That means unit matrix means first it is a square matrix. We have to understand properly. First it is a unit matrix. After this is a diagonal matrix, and also it is a scalar matrix. After that, all the diagonal elements are equals to 1. Then it is called a unit matrix. That means every unit matrix is a square matrix, every unit matrix is a diagonal matrix, and every unit matrix is a scalar matrix. So this is the unit matrix. Here this unit matrix is denoted by capital I. This is capital A. I written here capital A, but this unit matrix is denoted by capital I. So this is the unit matrix. It is denoted by capital I. But order of this matrix is 3 by 3. Simply it is denoted by I 3 by 3. Suppose if you want I 2 by 2. I 2 by 2 means this is 1 0 0 1. It contains 2 rows and 2 columns. So this is the square matrix of order 2 by 2. Now we have to discuss some more examples. Upper triangle. Okay, 1 minute. One more definition I will tell you. What is that? Suppose here capital A equals to Aij. This is the one of the matrix. It is a square matrix n by n. Then here, then it is said to be identity matrix or unit matrix. Then we can define this one such that Aij equals to 1 if I equals to j. Aij equals to 0 if I is not equals to j. I is not equals to j means non-diagonal elements. All the non-diagonal elements are 0. and I equals to j means diagonal elements. Diagonal elements are equals to 1. Therefore, then simply it is denoted by capital I. This is the capital I. So this is the one more definition of identity matrix. This is the very important to you. Identity matrix capital I equals to Aij n by n. This is the square matrix. Here Aij equals to 1 if I equals to j. This means diagonal elements. This is the diagonal elements, and I is not equals to j means it is non-diagonal. Okay, all the diagonal elements are equals to 1 and all non-diagonal elements are equals to 0. This is the one more definition of identity matrix. Now come to the upper triangular matrix. What is the upper triangular matrix here? Simply we can understand by using the diagonal matrix. See the next one. See the next one, upper triangular matrix. Upper triangular matrix means all the elements which are below the principal diagonal are 0, then it is called upper triangular matrix. See definition, in a square matrix, in a square matrix, in a square matrix, all the elements, all the elements below the principal diagonal are 0 is called upper triangular matrix. Upper triangular matrix. See an example here. See an example. Suppose for example, in a square matrix, that means first we have to take a one square matrix. Suppose for example, some p equals to, first we have to take the one square matrix, 2 minus 1 0, 0 6 3 0 0 1. So this is a square matrix. It contains square matrix. Here see, this is the square matrix. Square matrix means already you know it contains 3 rows and 3 columns. Therefore, it is a square matrix. All the elements below the principal diagonal. What is the principal diagonal here? First observe what is the principal diagonal. This is the principal diagonal. This is the principal diagonal. So principal diagonal. All the elements below the principal diagonal are equals to 0. So see this one, 2 6 1, this is the principal diagonal. Below the all the elements to the principal diagonal are 0 0 0. Therefore it is a upper triangular matrix. Therefore it is upper triangular. Upper triangular. Suppose the similarly we can define the lower triangular matrix. What is the lower triangular matrix here? The lower triangular matrix means similarly same thing. In a square matrix, all the elements below the principal diagonal, sorry, above the principal diagonal, below the principal diagonal are 0 is called a upper triangular matrix. Above the principal diagonal are 0, then it is called a lower triangular matrix. All the elements above the principal diagonal are 0. See example here. Some q equals to, the matrix q equals to a 0 0 b 0 c. Suppose this is some 2 and 3 5 c. See first of all it is a square matrix. This is the 3 by 3 matrix, therefore it is a square matrix. See the principal diagonal here. What is the principal diagonal? ABC is the principal diagonal. And above the principal diagonal, above the principal diagonal 0, 0, 0. Above the principal diagonal, all are 0, 0, 0, 0. Therefore it is it is lower triangular matrix. It is a lower triangular matrix. So these are the some of the important matrices.